let's do these 6 integrals. So the first one is the integral of arctangent square. Arctangent means inverse tangent divided by x squared plus 1. So we see an arctangent inside a square. So that's why we have to let u be arctangent. Arctangent x, which means inverse tangent, and then you take the derivative. So du, the derivative of tangent is 1 divided by x squared plus 1. And then dx, and then we isolate the dx on one side, so we multiply x squared plus 1 on both sides, x squared plus 1, and then du equals to dx, and then we replace the dx with the du, right? And then what do we have? Oh, the arrow is gone. Let's do that again. And then what do we have here? We have the integral of u square, right? So the integral of u square, divided by x squared plus 1. But don't worry about it. So when you replace the dx with du, you have another x squared plus 1 times dx, and then therefore those two x plus 1s got cancelled. So you only have the integral of u squared du. So that is just a simple power rule. So that is a u plus 1. And then 1 divided by the power plus c, and then you just put the x back to the u, so 1/3. The u is arctangent x raised to the third power plus c, so this problem is finished. All right, so the next one we have cotangent, so let's switch to that color. So we have integral, the square root of cotangent x times secant square x dx. So since we have a cotangent inside a square root, you can let u be cotangent. You might say, all right, so we have a secant x inside a square. Can we let u be secant? I haven't tried that one. You can try. If that works, then just do it. But the purpose of letting u be a cotangent x is this: u equals to cotangent x. Here is the reason. So the biggest reason is when you do du, that is equals to negative cosecant square x, which is just enough to get rid of the cosecant square x. So that's why we let u be cotangent x, and then 1 divided by negative cosecant square x du, that is equals to dx, and then we rewrite that, so that is equals to the integral, and then square root of u, which is u to the 1/2 power, and then cosecant square x times 1 divided by negative cosecant square x du. The reason we do this is we replace the dx with this piece. That's why we call this u substitution. All right, we change the variable from x to u. Now, as you can see that the cosecant square can be cancelled, and there is a negative in there. Don't forget that. So now we can integrate. So how do we integrate? So we take the half plus 1, right? So 1/2 plus 1 is 3/2. And then the reciprocal of that is 2/3. Keep the negative in front, and then plus c. And then now you put the cotangent back, so that is negative 2/3. And then you use a parenthesis, cotangent x to the 3/2 plus c. The job is done. Moving on to the next one. So the next one, I hope that you already copied the 6 integrals down. So I'm going to move on to the next one. The next one is integral of sine of 2x. So we have sine of 2x divided by 1 plus cosine square x dx. So this one, should I let u be the cosine sine 2x or what? So this one, I am going to let u be 1 plus cosine square x. So u is equals to 1 plus cosine square x. I know that is not obvious. That's why I picked this problem, and that's why you have to do your homework. And then du is equals to, the derivative of 1 is 0, and then cosine square x, still remember how to take the derivative of this? You have to use the simple power rule and then a product rule, right? Because cosines, we have this. You have to bring the 2 down first. So you bring the 2 down, and then you have cosine x, and then you have to multiply the derivative of cosine by chain rule. So the derivative of cosine is negative sine x and then you do the dx. All right, so let's erase that to save some space for myself. And then you put the whole thing to the other side. So you have 1 divided by negative 2 sine cosine. And then du, that is equals to dx. So since we know what dx equals to, we are going to replace the dx with this piece. Okay, let's change the variable. So we have the integral of sine of 2x sine of 2x divided by, and then 1 plus, oh, that is no longer 1 plus, so that is u now. And then replace this piece, so we have multiply 1 divided by 2 sine x cosine x dx. Okay, so now you are going to ask me a question. Hey, the sine 2x cannot be cancelled. Oh, let me change that. It's not dx, that is du. That is du. Now, the question that you are going to ask me is, okay, hey, the sine 2x cannot be cancelled. All right, sine 2x is not the same as 2 times sine x. All right, they are not the same at all. So there is no way to simplify anything, and that's why I picked this problem. So one thing that you can do is you have to use the double angle formula. So double angle formula. So let's do that in another color. So we have to use double angle formula. What is that formula? The formula is sine of 2x, that is equals to 2 times sine x and then cosine x, and which is the reason why I let u be 1 plus cosine square x. So I know this is not obvious. That's why I picked this problem for discussion. So this one, the sine of 2x. Now, so let's just rewrite this. I don't want to erase another line. So let's just cross this out. Don't erase. So when you go back to your notes, you know what happened. So 2 times sine x and then cosine x, right? So you can draw a little arrow to, so when you go back to your notes, maybe 5 days later, you know what you did. Okay, now what is my next step? My next step is I have to get rid of the 2 times sine x times cosine x, right? So we have to get rid of this and this. So what do we have left? We only have 1 divided by u, and one thing that I forgot is here there is a negative, right? So there is a negative, so there is a negative right here. Okay, so we have a negative 1, and the integral 1 over u du. Is this a simple power rule? The answer is no. 1 over u, integrate that, you get an ln. So that is negative ln, absolute value of u plus c. Is the absolute value optional? The answer is no. It is not optional. You can take away the absolute value only if you can prove that the quantity inside the absolute value is absolutely positive, and which is the reason why I picked this problem. So we have negative ln. What goes to u? So that is 1 plus cosine square x. Cosine square x is positive, right? Because you square. So a cosine is bouncing between 1 and negative 1 if you recall the graph of cosine, but once you square the cosine, then cosine square x is between, the range is between 0 and 1. So that's why cosine square can never be negative. In addition to that, you add 1 to it, so you have a positive quantity. You add 1 to it, that makes even more positive, right? So now the absolute value can be omitted. Then you have to use a parenthesis. Is this action optional? The answer is no. This is not an optional action. So you have to think about this when you solve this type of problem. And that's why I bring this problem. And then you have to add c to it. When you do your homework online, I'm sure if you keep the absolute value in there, you will not get points for it. Right? Very good problem to discuss, right? The next one that I would like to discuss is the integral of cotangent x dx. Oh, you don't have to go back up because I will write the integral for you. So we have cotangent x dx. Cotangent x dx. Wow. How do we do this? So first, let's rewrite this. So that is the integral of cosine x sine of x dx. Okay, So now let's let u equals to sine x. Can you let u equals to cosine x? I haven't tried that. You can try, but I decide to let u be sine x, and then du is equals to cosine x dx. So we have 1 over cosine x du that is equals to dx, and then we will replace the dx with that. And then we have the integral of cosine x divided by u, and then the dx is 1 over cosine x, so which is perfect. We can cancel them, and then du, so we get rid of the cosine, so get rid of the cosine, and then that is 1 over u, right? So that is 1 over u, which is not a simple power rule, so that is absolute value ln u plus c, and then since this one, the u is sine, then you have to keep the absolute value. Why? Because sine can be positive and negative. So let me recall the graph for you. So this is the graph of sine, right? So sine is oscillating between 1 and negative 1. So sine can be positive, 0, negative. So since sine can be negative and ln negative is undefined, you have to keep the absolute value. The absolute value is not optional. Okay, next one. The next one, let's switch color again. So the next one is, wow, the next one is pretty long. That is 1 divided by, we have 1 minus x squared, and then inverse sine of x, and then dx. So this one, I am going to let u be inverse sine. So u is equals to inverse sine of x. You learn this in differential calculus, the derivative of inverse function. If you don't remember this at all, you have to go back to your the what is that called? That is called the derivative of inverse function. I am sure I have a video in my channel, the derivative of inverse function. But if you don't want to go back, it is fine. Just a matter of the formula. So du is equals to the derivative of inverse sine is 1 divided by the square root of 1 minus x squared dx, and then multiply that on both sides, 1 minus x squared du, that is going to equals to dx. That is just enough to get rid of the square root in the integrand right there. So that is going to be 1 minus x squared u, and then square root 1 minus x squared du, and then you get rid of the square root, so you only have a 1 over u left, so that is equals to the integral of 1 over u du, so that is ln absolute value of u plus c. Again, the absolute value is not optional until you can prove the stuff inside the absolute value is positive. So this is ln absolute value of inverse sine x plus c. Can I remove the absolute value? The answer is no. That's why I pick this problem. What is the graph of inverse sine? So the graph of inverse sine is, the inverse sine is between pi over 2 and negative pi over 2. So pi over 2, negative pi over 2. And then the graph goes like that, and then ends right here. So this is negative 1, and this is positive 1. So since inverse sine can be positive, 0, or negative, then you cannot omit the absolute value. All right. So let's do the last one. So the last one we have, well, the last one is a good one. If I make an exam right now, I will just put this on the exam. 1 plus x divided by 1 plus x squared dx. This one you have to break this down into two integrals. I know in this video, everything you solve in here is not so obvious, right? That's why I pick these problems. So you have the integral 1 divided by 1 plus x squared dx plus the integral of x divided by 1 plus x squared dx. So how do we split that up? So this is 1 goes to here, the x goes to here, the plus goes to here. Just like that, just like 2 plus 3 divided by 5, that is equals to 2 over 5 plus 3 over 5, just like that. Okay, so that divides up into two integrals, and I decide to let u be 1 plus x squared, so du is equals to 2x dx, and then 1 divided by 2x du is going to equals to dx. And then first of all, this integral, what is that equal to? That is equals to inverse tangent of x. So let me write the formula for you. So the formula is you have the integral 1 divided by a squared plus x squared. A is a constant. And then dx, that is equal to 1 divided by a inverse tangent of x divided by a plus c. So in this case, a is equals to 1, so that's why you don't see any fraction. So that gives me inverse tangent of x. Can you just do a plus c for a separate integral? The answer is yes, absolutely. And what about the other one? The other one is x divided by u, 1 over 2x du. And then since the x got cancelled, what do we have left? So we have inverse tangent x plus c, and then plus 1/2, right? The integral of 1 over u, that is absolute value, ln absolute value of u. So absolute value of u plus c. And then we have inverse tangent x plus c plus half ln. Do we need the absolute value? The answer is no. 1 plus x squared is positive, absolutely positive. That is a parabola, shift 1 unit up. So you square a quantity which is positive, you add 1 to it, that is guaranteed positive. So you can just use the parenthesis plus c. So the last little issue that I have to point out is you have a plus c, you have a plus c. Should I just keep 1 plus c or 2 plus c? So here is my answer. Constant is a constant. So a constant plus another constant is equals to a constant. So all you have to do is just keep 1c plus 1/2 ln, and then 1 plus x squared, 1 plus x squared, just keep 1 plus c. You don't need to do c1 or c2. Constant is a constant. Constant plus a constant equals to a constant. So that's it. That is your final answer, and that is also the end of this video. If you think I picked a good problem, I gave you a good explanation, let me know in the comment below. Like the video for me, share the video for me, subscribe to my channel if you haven't done so. Appreciate your help and support to the channel. Signing out for now. See you all in the next lesson.